Okay, forgive me if the writing on this is weird. My slate is acting up on me. In this video, we are using similar figures, and we're talking about the ratios of the perimeter and the ratios of the sides, the area ratio and the volume ratio. I will refer to these generally as PAV 1, 2, 3 problems. And that's the power on the ratio. So if we're talking about the side ratio or the perimeter ratio, that's just A to B. If we're talking about the area ratio, and that could be lateral area, surface area, or just general area, that's A squared to B squared. And then if we're talking about volume, that's cubed. So it's A cubed to B cubed. So here it says use this information to answer the following questions. We're not actually using the ratios for this particular problem. This particular problem is just asking if they're similar or not. To tell if figures are similar or not, you compare their corresponding pieces. So like on these cones have radii and heights labeled here. So the radius of the small one to the radius of the big one would be 3 to 5. And that should be equal to the height of the small over the height of the big one if they are going to be similar. And 3 to 5 does not equal 4 to 10. So since these are not equal, they are not similar. Sorry, my handwriting is going to be terrible in this video. My slate's not working right, but I don't have time to fix it, so we were just going to go with it. On question 2, notice that the first one gave you the diameter, which means that we need the radius of it because the other one gave you the radius. The radius of this one would be 2.5 meters. And so we're going to be using that radius and the other one's radius. So 2.5 over 5 is the small radius to the big radius. And then the small height to the big height be 7.5 to 15. And so these do both equal to 1/2. And so yes, they are similar. So you just always check their corresponding measurements and make sure they reduce to the same scale factor. Here we are given cylinders A and B, and we're told they're similar, and they gave us a scale factor of 2 to 5. So A to B is 2 to 5. That is the scale factor, it's the side ratio, it's the perimeter ratio. They want us to find some surface area, so we're going to be needing the area ratio and the volume, so we'll need the volume ratio as well for this problem. And they gave us cylinder A, so we're going to be finding cylinder B for these items. So the scale factor is 2 to 5. Which means that the area ratio is going to be 2 squared, 4, and 5 squared, 25. And the volume ratio is going to be the original scale factor cubed. So 2 cubed is 8, and 5 cubed is 125. And so, again, I'm sorry, the handwriting is not working on here for me. So we're going to use the area ratio equal to the area of A, because this is A to B, so area for A was 96 pi. And then find the area for cylinder B, so I'm just going to call it B. And so we're going to cross multiply, which will give me 2400 pi equals 4b, and then divide by 4 on both sides. So 2400 pi divided by 4 is 600 pi for B. So this is the surface area. And that is feet squared since it's area. Again, I'm so sorry, this handwriting is awful. Then for the volume, we're going to use the volume ratio, which is that 8 over the 125, and set it equal to the volume of the small one, 128 pi feet cubed, over the volume of cylinder B. And so we're going to cross multiply. And so 125 times 128 is 16,000. And that had pi on it, so don't forget the pi there. That equals 8b, and then we're going to divide by 8. And so that's 2,000 pi feet cubed for the volume of B. So there is a similar figures using surface area and volume problem. Okay, this one is pretty much the same thing going on. It's cones, but we're not even using the formula. We're just using the ratios to solve with. So we've got A to B is this ratio of 5 to 2. That's the scale factor or the side ratio. It's also the perimeter ratio. So the area ratio, which we are going to use some surface area, so we do need that, is 5 squared is 25 and 2 squared is 4. Area ratio is going to have 25 and 4. Volume ratio is cubing the 5 is 125, and cubing the 2 is 8. So there's our volume ratio. I feel like a kindergartner with my handwriting. And so they want the surface area and volume of cone B, and they gave us the surface area of cone A right here, and they gave it to us as a decimal, not in terms of pi, so we were going to have a decimal answer. So I'm going to use my area ratio, 25 over 4, equal to the area. They gave me A, and A was on top, so that over the area for B, and then we're going to cross multiply and solve, and when we do that you should end up getting, so we do 4 times 2356.2 equals 25B, and then divide by 25, and so the surface area of figure B, and they wanted to 2 decimal places, gives me 376.99 centimeters squared. Now that I think about it, I'm wondering, did I put my units on the previous one? Ooh, I did. Good. Be sure you put your units. You don't want to lose points for that. So here is surface area of B, 376.99 centimeters squared. And then for the volume, we would take our volume ratio, that 125 over 8, equal to the volume of A, 7,950.9, over the volume of B, and cross multiply, so 8 times 7,950.9 equals 125V, and then divide by 125, and you get the volume of figure B to be 508.86 centimeters cubed. So there's the volume of B right there. And then the last one, thank goodness, because my handwriting on this is going to make me crazy. A store sells birdseed in 2 sizes of cube-shaped blocks. The smaller block measures 3 inches on one edge and sells for $1.99. The larger block measures 5 inches on an edge and sells for $5.99. Which block is the better buy? Justify your answer. What type of problem is this? Well, if it's a block of birdseed, then it's pretty much a solid chunk of birdseed in the shape of a cube. And so the volume of it is what amount of birdseed you get for your price. So this problem is a volume type of problem. So if we take the price and divide it by the volume, we will get the price per cubic inch. And so we're going to calculate the volume of each cube and divide the prices by that volume. So the small one sells for $1.99 and it has a 3-inch edge. And so this means that this cube, you know, has 3 by 3 by 3, and so the volume 3 times 3 times 3 is 27. So if we divide 199 by 27, because that would be the volume of that cube, and we did volume in the previous video, so hopefully that part made sense. 199 divided by 27 is $0.07. So 7 cents per cubic inch. On that one. And then the larger one has a price of $5.99 and has an edge of 5. So 5 times 5 times 5 means it has a volume of 125. And if you do $5.99 divided by 125, you get 5 cents per cubic inch. So it says which block is the better buy and to justify, and so I'm going to use typing. This handwriting is so bad. So the larger one is a better buy because it would be 2 cents cheaper per cubic inch. There we go. So those are the notes for similarity, just like before where we had our area ratio and we had to go back and forth between area ratio and side ratio by squaring and square rooting. If they gave you the volume ratio and you want the side ratio, you have to cube root. There was no problems like that on these notes, but sometimes that happens. So if they give you the volume ratio and you need the side ratio, you'll need to cube root it. Sometimes they give you the volume ratio and you need the area ratio. In that case, you would need to cube root the volume ratio to get the side ratio, then square it to get the area ratio. But we'll be practicing that on, using these on our assignment. But remember, PAV 1, 2, 3, the perimeter ratio is the same as the side ratio. Area ratio is that squared. Volume is that ratio cubed.